Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 2090 K-radius subarray averages. This is a medium difficulty Leetcode problem, and in the problem description, and bear with me because I'm going to read it out, we're told that we're given a zero-indexed array called nums of n integers and integer k. And we're told that the k-radius average for a subarray of nums centered at some index I with the radius k is the average of all elements in nums between the indices of I minus k and I plus k inclusive. And if there are less than k elements before or after the index I, then the k-radius average is -1. So when we're told that we want to build and return a new array called averages of length n, where averages I is the k-radius average for the subarray centered at index I, and the average of x elements is the sum of the x elements divided by x using integer division. And we're told that the integer division truncates towards 0. So in this example here, the actual result is 2.75, but that just truncates to 2. So we're going to be using Python, and so we're just going to be using a division, integer division operator to solve this requirement over here. So this is not something we need to worry about. And we also don't really need to focus a lot on this because it is quite confusing, and it does make understanding the problem a bit more difficult. But actually looking through the description, looking through an example, really makes a lot more sense. So in this example, we have a list 74391856 and k is 3. And so we can see here that the output here for elements which have less than k elements before each index or after each index. So this satisfies this requirement over here. So if there are less than k elements before or after the index I, then the k-radius average is -1. So these elements here are marked as -1 because they don't satisfy that condition. These elements, though, these elements that you can see as set to 544, they basically are elements where there are more than k elements before or after, so enough to satisfy the condition such that we can perform the logic that we're told that we need to do. And that is, for each, we basically want to get the sum of the subarray. So I is going to be here in the center, and we want to get everything around the radius of k. So that's 1, k is 3, so that's 1, 2, 3, and then 1, 2, and 3. So, and when we do this for each element that has enough k elements after it or before it. And so in this example here, we can see that what we want to do is get the sum of the subarray. So get the sum of all of this, and then basically divide it by the size of our window as such, and then that will be the average for that position in our new list. So I hope that makes a bit of sense. It is a bit confusing. I definitely would recommend mulling over this this whole kind of example and the subsequent examples, and really it's hard to understand, but once it does click, it'll make more sense. And then come back to the video and we'll actually go through the solution, writing this up with code. So that's what we're going to do now. So let's get this coded up in Python. We want to set n as a separate variable just because we're going to need it for ease of use, and we're going to set n equal to the length of nums. Then we want to set our result list. We can call it averages, but let's just call it result -1 times by n. So we want to set our entire list to -1 by default, and then we want a window size. So our window size, what is our window size going to be? Well, we know we have I, and then to each side of I, on the left and on the right, we have k elements. So that equals 2k. So 2k plus I. So that's, 2k plus 1 is going to be the size of our window. So, and again, if you haven't got it by now, this is a sliding window problem. So we've got our window size, and we want to say if n is less than the window size. If n is less than the window size, well then we just return result. We just return the fact that it'll all be -1s, but we can't really perform any more logic because n is less than the window size. Otherwise, we want to naturally get the window sum. So the initial window sum is going to be equal to the sum of nums up to window size. Okay. So, and of course we want to set result k. So result k is going to be equal to window sum divided by window size. So that's going to be the initial value for k. And then we want to say for I in range, and let's say we've already done k, so we can just say k plus 1 up to I minus k, because we only want elements which have enough k elements before or after it. Let's create a new window sum. So window sum is going to be, well, we want to remove the leftmost element, so we just want to say minus I minus k plus 1, and we do want to add to it. We want to add to our window sum the element that we've just come across, or that's next after the window. So we want to say nums k plus 1, or nums k plus I, or nums I plus k, just for the sake of brevity. And then let's say result I is going to be equal to, and it's just going to be equal to this again. So we want to calculate the average by dividing the window sum by the window size, and then we can return our result. So let's submit our code. And we get a issue here because this should actually be equal to n minus k, not I minus k. And it doesn't pass test cases. I wonder why. Let's go through our code. Return result. Window sum is nums, window size. We go for I in range k plus 1, n minus k, minus equals nums I. This should be a minus. Okay, let's check how code works again, and it does now. It passes all 40 test cases, so we were adding 1 when we should have been subtracting 1. So that's the code for the problem, guys. Let's look at the time and space complexity, and for both the time and space, it's going to be equal to bigger of 1, so linear time and linear space. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.